Okay, let's head into some geometry. And you see somewhere over here is the picture. And then, wait for it. We're going to prove that opposite angles of a cyclic quadrilateral are supplementary. And then they're the pictures of the opposite side. So, yeah. Okay, so let's have a look here. So we got two distinct ways of proving this, or there are probably a few. But there were two that you came up with. Well, maybe not you, but you as a collective. And each of them started off by drawing some radii. So I'm just going to head straight through this as kind of efficiently as possible to go. The one option is that you drew these radii, OB and OD, and I'm going to run through the thinking here and then write it down later. So we're going to construct those radii. You're going to say, okay, well, let's let that thing equal x. Then this is going to be 2x. Angle at center equals twice angle at circumference. And then, well, let's go to this reflex angle here. Well, this is 360 minus 2x because of angles around a point or revolution. And, well, if we do that whole angle at center is twice angle at circumference, this is 180 minus x. Hey, look at that. If you add these two things, 180 minus x plus x, they add up to 180. Now, to prove the other part, well, angles in a quadrilateral add up to 180. So if those two add up to 180, A and C, then B and D need to add up to 180. So let's capture that thinking, and just because the layout of our proof is also important to get right. So let's have a look here and say, let A equal x, construct radii. What are they? BO and DO, Bodo. And then we've got, well, angle. Now, we have to talk about BOD is that little one there. So what you can do is call this O1 and O2. So you could call that O1 equals 2x, angle at center, equals 2 times angle at circumference. And we've got O2 equals 360 minus 2x because of angles round a point, or you may have used revolution. And if you wanted to call this angle BOD or DOB, maybe you would have called this BOD and the other one reflex BOD. That's also a way to reference those. And then finally we've got, well, angle C equals 180 minus x. And the reason for that is angle at center equals 2 times angle at circumference. And therefore we've shown that A plus C equals 180. Okay, done. And we've shown the other one because of angles in a quad if what. So that's the first way of showing it. And the second way of showing it is to, let's just get our picture here. So our second way of doing it is also to construct radii, and interestingly, there's another way of doing it. So let's construct that one looked a little bit off. Okay, so there are radii, and what we could do is let each of these angles along here equal something. So I'm going to call this A, and if that's A, in fact, I'm just going to call that A, that's B, that's C, that's D. Now, because we've constructed these radii are of equal length, so this equals this, which means we've got an isosceles triangle, so this must also be B. Similarly, this is an isosceles triangle, so that must be C. This is an isosceles triangle, that must be D. And this one here must be A. So the way this proof looks now is that if we add all of those things together, we should get 360 because it's a quadrilateral. So we could go A plus B plus B plus C plus C plus D plus D. So I'm just going to do this here because I want to show that thinking, but I'm leaving space for our constructions. C plus D plus D equals 360. Reason, sum of angles in a quadrilateral. Okay, well, kind of there now, because if we divide, we've got 2a plus 2b plus 2c plus 2d. So in other words, what we've got, and I'm going to just going to show this step. I don't think it's entirely necessary, but let's go. Plus 2d equals 360. Bit of algebra, common factor. A plus b plus c plus d equals 360. Divide both sides of our equation by 2. and we've got A plus B plus C plus D equals 180. You could well have got straight from that step to that step. But wait a second. A plus B, well, wait, the way I ordered this. A plus D, well, isn't that just the same as A? So that's A. And kind of similarly, we've got B plus C. Well, B plus C is this angle down here, so that's just angle C. So what we've shown is that A plus C equals 180. Cool. So nice proof as well to do it that way. And so we just need to capture our thinking before, which is first off, we constructed, now this time we constructed 4 radii, all of the options, OA, OB, OC, OD. We let a whole lot of these angles equal things. Now, this I find a bit of a pain to do, but let's just label these maybe 1, 2, 1, 2, 1, 2, 1, 2. So let A2, we started with those one, I think, equal A, and then all of those, right? So B2 equals B, C2 equals C, and D2 equals D. Feels a little long-winded, but okay. And then, therefore, well, let's just check this. B1 equals A, and I'm going to be a little bit lazy. I think you're allowed to be a little bit lazy on this one to say, well, I'm not going to go B1 equals A because of isosceles triangle. B1 equals A. C1 equals A equals B because of isosceles triangle. I mean, those should be each of their own, but you know what? Let's just do this. C1 equals B. D1 equals C. D1 equals C. So this one's definitely a pain to kind of capture all this thinking. And then A1 equals D. And what's our reasoning? Well, isosceles triangles from all those radii. Again, each of those should have their own reason. And therefore, okay, well, that's fine. Then we can head into what we headed into there. Definitely feels long-winded to write down, but that's that. So, you know what? Go and make it maths.